Well, I am super excited to have Chris and Jacob here today because I've had so many conversations online with them, but we never met really. So we're kind of virtually meeting right now. So I wanted to tell you, so what happened was in April, the AIA had something in the newsletter about a little ADU that was built that was, I don't know if it was carbon neutral, but it was very carbon considerate and, zero net energy stuff. And I looked at that and they had a video how they built it. It was super exciting. And it's, they were called OBY, Our Backyard. And they had a whole concept of how to build these things for people in their backyards and increase density and reduce carbon and be conscious and also like have a whole concept of community. And they have an organization that's called Co-Everything. And they had an open thing where you can like click and make an appointment. And I thought, man, they know something about carbon and they make it really manageable. I need to talk to them because I want to develop a curriculum for little people like me to learn how to change their work. And so then Declan, who is one of the owners, he got in touch with me and we had an interview and talked about it. And then he said, Jacob and Chris and Ace, who is not here, they know all about this. And then he sent me a link to their presentation at I think it's called NESEA, NESEA, Building Energy Boston from 2019. Now that is 3 years ago. And it felt very cutting edge to me when I listened to it. It's an amazing presentation. And so eventually, through a bunch of things, I think eventually I found you guys at this Thursday, the beer and building sciences or something. You presented there. And finally, I got an actual link to your emails and could contact you. And so that's how this started. You guys have been super generous. I mean, the whole idea of making this accessible and having people be able to improve their work, firms that don't have, a whole section of their business dedicated to whatever it needs to be advancement, I think is just awesome. And so I'm totally looking forward for you, to you presenting this tool and sharing this with everybody here. And that's it. Thank you.
Okay, well, thank you for the invitation, and really glad to be talking to everybody here today. So Jacob and I are going to kind of share the presentation. I'm going to kind of do a first half on the tool itself, and then Jacob is going to follow that with a bit of insight on how you would sort of incorporate that into your practice and what you how it sort of like fits into your workflow and things like that. So I'm going to share my screen with you here, and I will get started. So a little bit of introduction to myself, and I guess Jacob, you can do that when you start presenting. But
perfect.
I'm sort of here. I wear two hats these days. One is a more recent hat. I work with RMI in their carbon-free buildings unit now, and so have been there for about 9 months. And sort of prior to that, and still today, I'm also with Builders for Climate Action. I was a founder of that group, and it's sort of with that hat on that I was part of the team that developed this tool and took part in a bunch of the studies that are folded into this presentation. So I guess that was a great introduction, because my first steps into this field of trying to figure out what's the carbon footprint of the materials in my buildings also came as a practitioner in a small design build firm. And really in 2012, we just decided we wanted to know what that answer is. Like, what is the carbon footprint of this building we're doing? We had been able to develop and and find metrics for all the other parts of the building that we were concerned about. We had good energy models, and we were tracking our waste, and we were keeping track of materials and chemical content, and all of those sorts of things. But when we kind of turned our attention to what's the carbon footprint of these materials, and attempted to figure that out, we quickly learned that it wasn't so easy to do. And so that became a bit of a personal obsession for me to figure it out. And in 2016, I took a year off from that practice to go back to school, and did a master's thesis called Opportunities for Carbon Dioxide Removal and Storage in Building Materials. And in doing the study there, I kind of built a prototype of this tool, and then it's since been developed into this publicly accessible tool called Beam. So the reason that I had to develop a tool for my own study is that when I was attempting to figure this out, and specifically for small buildings, what I realized was the tools that were available at the time were really focused on big buildings. So, if I was trying to model something, with a concrete frame or a structural steel frame and curtain glazing and all of those sorts of things, there were some tools available to do that, and I could have picked one of those to do this. But when I was looking for frame wall assemblies and the kinds of roofing and windows and cladding and all of those materials that are more common to small buildings, the tool just wasn't there. And it seemed like a big gap because whereas big buildings get a lot of attention because they're big and the firms that do them are big and have sustainability experts on staff and things like that, small buildings are still a lot of what gets built in North America. Somewhere around 50% of all the square footage that gets built in North America is small buildings, and not having a tool to be able to study those seemed like a big gap, and was a gap that at first I needed to fill for myself, and then it became something that I could share with other people. So like I said, these small buildings, they are quite different in the types of materials and assemblies they use, and in fact in their emission profiles because of those differences. There's less reliance on concrete, steel, and glass, but there is a lot more insulation and cladding to floor area ratio, and there's a lot more competition in terms of variety of products and substitutions that are available. There's lots of different kinds of flooring, lots of different kinds of cladding, lots of different kinds of windows and insulation and things like that. So, product choice ends up being a big part of what you want to be able to discern from a tool. So from building the tool out for my own study and then applying that tool to some other studies. So I was, after the thesis, I was asked by the government of Canada and the city of Toronto and Vancouver and a smaller city called Nelson separately to do a bunch of studies as they were trying to figure out, what's the extent of embodied carbon from low-rise homes. And this is one set of results from the Toronto region study. It's a good study because we were looking at over 500 as-built homes. So we were able to work directly from the plans from the developers. So we were getting accurate material counts and a good look at what materials they were selecting as well. And what we found consistent across all of the studies is that, in this space, the buildings have a really wide range in terms of what the actual carbon footprint of the materials is, from, upwards of 0.5 ton per square meter of floor area, down into the low hundreds. And in fact, some of the other studies had numbers that were even lower than that. But what's interesting is that across all of these studies, this average in the range of about 190 to 200 kilograms of emissions per square meter is pretty consistent across all of those studies. And so, it starts to point to the fact that somewhere in that range, there's a benchmark that we might be seeing. The other thing that the studies really showed, and I think this is what has sort of spurred so much interest in the tool and in the topic in general in the small building space, is that by substituting not that many materials necessarily, there's a whole lot of low-hanging fruit in this small buildings world. So this is an example from the Toronto study of a home that we were able to model from its as-built plans that had about 81 tons of emissions for the whole house, and that equated to just over 260 kilograms of emissions per square meter. And through a handful of steps, choosing better concrete, substituting some insulation products, substituting some cladding products, and picking flooring and drywall products that were sort of best in their category, we were able to sort of show that in the case of this house, there was a 75% reduction to be had through some pretty simple steps. And we'll dive into this a bit more later on in the talk, but the whole reason the tool exists is to make gains like this really obvious and make it easy to figure out, what are these steps that would result in really big reductions. So the tool is a spreadsheet-based tool. It operates in Google Sheets. So the sheet and all the data are in the cloud. You work with it on your desktop. And it kind of does a few things. It enables you to do direct side-by-side comparisons of different materials. It allows you to model out different assemblies, and then also build out whole buildings as well. So, and we'll kind of go through what those steps look like. I will just say, actually, before I move on, that the idea for the tool, when I first started building it, this was a tool for me. I am not a computer savvy person, and I'm not a very tool savvy person. So the whole idea was to build something for myself that I could figure out and use. And so I think it is a very approachable and easy to use tool, but aiming for pretty low bar in terms of me as a user. So in the tool, we decided early on that we were going to focus on the product stage of emissions from the life cycle. So in life cycle assessment terminology, that's A1 to A3, which is sort of raw material supply, transportation to factory, and manufacturing. So those are the emissions that we're capturing in the tool. And we are sort of specifically not looking at transportation to site, construction or installation, any use, maintenance, or repair, or any end-of-life figures as well. So really focusing on that product stage. And the reason for that, there are a few reasons for that. The biggest one is that's where most of the emissions happen. So depending on the product, obviously different materials have different emission profiles, but typically between 65 and 85% of all the emissions that will happen because from a material over its life cycle happen in this product phase. So it's a way to capture the bulk of what's going to happen. It's also capturing emissions that are occurring now and addressing today's emissions and being able to sort of eliminate or reduce those is a lot more impactful than things that might happen at the end of the building's life. And also out of the data that we have, this is kind of the piece that we know is as well measured and consistent and reliable and accurate as possible, because all the data is coming from the manufacturers and from the factories. As we move along the life cycle, there's a lot more uncertainty, trying to figure out, how far material traveled to a particular job site and by what type of vehicle it got there. There's a lot of uncertainty around that. What types of energy are being used and how on site is another uncertain thing. How often the materials will be maintained and repaired and replaced is also questionable, and so is how long they'll last and what happens to them at the end of their life. So I definitely don't want anybody to leave thinking that we said, oh, all of that other stuff doesn't matter. I think it matters a lot, but I think in terms of a tool that's trying to show you actionable numbers, the product phase are the actionable numbers we can show you. And these other phases are things that, you need to think about individually on a project, the distance you are from a material, how it gets put in site, what your sort of the sort of waste and recycling scenarios are in your area. It's very hard to attach reliable numbers to those, but we feel like we can attach reliable and really important numbers to that upfront product phase. So the way the tool works is that we're taking those product phase emissions factors, it's called the GWP factors, or global warming potential factors, from environmental product declarations. So these are an ISO certified way of describing what needs to get counted and how it needs to get counted, and drawing boundaries around the equations for figuring out emissions from materials. And those are a third-party verified document, so they're standardized and quite reliable. So we kind of have in the background of Beam all of these GWP factors from these EPDs. From that, we subtract biogenic carbon storage from the amount of emissions, and we can get into that in a bit more depth later on. But for now, I'll just sort of say that's what we do. And we sort of do that conservatively. We figure out how much biogenic carbon is in the material, and we subtract 10% from that, and try to offer a relatively conservative figure for that. And then the tool works by the user inputting dimensions, and the tool using those dimensions to do material takeoffs. So if you give us a wall area in the tool, then the tool will kind of convert that wall area into an amount of, say, framing or insulation or whatever the material is that will be part of that wall. And so once all of that math happens, you get a net emissions score for that particular material. So that's kind of what's going on in the background, line by line in the tool. And before we look at the tool, it's also important to sort of say what's actually in the tool and what's not in the tool. So what is included right now are as many options as exist for the structure, enclosure, and partition materials in low-rise buildings. And what's not included is mechanical, electrical, and plumbing materials, appliances, finishes, millwork, like yard work, like driveways and things like that. Few reasons for those distinctions. One is almost all the good and available EPD data comes for the structure, enclosure, and partition materials, and there's hardly any of that kind of information available for the ones here in red. And also there's an awful lot of variation in the results in the structure, enclosure, and partition section. And so there's a lot of actionable things that we all can do by making choices in those areas. It might be that there is less so in these other areas, especially around mechanical, electrical, and plumbing. Even if you know the carbon footprint of all the drain pipes in the house, you're still going to have drain pipes. You're not going to decide to not have drains or not have water or not use electricity. So those numbers might be useful to us when we can discern them, and it would be great to be able to do that. But they're perhaps less actionable in terms of the choices we can make on the design and construction side. So the tool itself, like I said, it's a Google Sheet application. It's free, it's online. This is the URL to get there at buildersforclimateaction.org. You can go to the page. The tool is free. We do ask that you contribute to help us maintain and update the tool. And so you can just sort of click on the Get My Copy of Beam link on that page, and that's how you start. And so essentially the tool is pretty straightforward. There's a project page where you kind of input project information on the top part of the page. Most of that is just to allow you to sort of track and identify the project. And like I said, it's mostly driven by inputs of some basic dimensions of the building. So just these 10 or 11 that you see here is what all the the inputs that are required. There's a separate section of inputs for garages. If you're sort of having an attached or detached garage, we kind of separate those. So there's another set of inputs for the garage, but it's a fairly light number of inputs that are required. And one of the ways people use the tool is to just do pretty basic comparisons of materials or assemblies. So you can see, in the fields right now, I just have some nice round numbers, and that's quite often what I'll do and what lots of users of the tool do if you just want to be able to see how one material or one assembly would compare to another, or you can get very detailed here and build out a model for a whole building quite accurately. And then the sheet is made up of a number of tabs. Each tab is one assembly of the building. So the one that's highlighted here is the exterior wall assembly, and you can see it's broken into categories. So as you scroll the sheet, you'll find structural framing, sheathing, cavity insulation, continuous insulation, all the parts that would go into that particular assembly. There are sometimes additional inputs you need to make. So if you want to compare insulation, you have to input an R value, because that's one of the multipliers that the software needs to figure out the quantity of material. And once you have a dimension and an R value, you can see the net emissions of a whole range of different materials that you could use for that part of the assembly, in this case, cavity insulation. So there are 12 of these assembly sheets. Kind of, it's a bit like building the building from the ground up, starting with footings and slab, and moving along until you get to the roof. And like I said, there are some additional input factors in some categories: framing, spacing, wall thickness for where you're specifying concrete walls, bar length for rebars, a few things like that. That we need in addition to the dimensions that you put in, but they're pretty minimal. When you have completed your inputs on all the different tabs, there's a review sheet that allows you to see all the materials that you've selected. They're color coded by the assembly that they're tied to. You get to see all the emissions. You get to see a total for the building up on the top right, and you also get sort of cued as to which are your big emitters in the sort of like darker orange color, and your carbon storing materials, if there are any, are highlighted in green. So the review page is really great to give a good overview of the building, but also we use it for quality assurance. You get to go through and your model and make sure that you've actually included all the materials that you intended to include, and that you haven't input anything twice or wrong or missed anything. And then there's a results sheet that comes at the end. It has a bunch of different outputs. It gets exported as a PDF, so it's easy to kind of print to share with other people on the design team and clients and stuff like that. And it gives you a bunch of feedback on the results for that particular model. There's also a save function, so you can create, say, a baseline. If you're looking at a whole building, you can create a baseline building, save it, and then make a new version of that building and change a handful of materials, and then be able to see what the results are. And you can do that as many times as you want. You can have as many different buildings and models and versions of buildings as you want. There's sort of an unlimited save quantity in the sheet. And some of the things you get from the results report are this color-coded graph of all the different assemblies with a bar graph that's kind of showing you where the bulk of the emissions for this building are. So you can see in this one, footings and slabs, foundation, and the garage are the three big contributors. So that makes it easy to decide that, well, that's where I need to go if I want to make an impact here. You also get this output that's showing you the total project emissions but it's also showing it to you as an intensity per square meter or square foot. You can toggle the tool between metric and imperial. So in this case, we're looking at metric, but of what the emissions are per square meter of both heated floor area and total floor area. And then this little bar slider kind of shows you where this building, where its material carbon intensity rates compared to other buildings that have been input into being. So, whoever's result this is, they're actually sort of on the great side of things, but that bar would change depending on your results. And then you're also shown what are the top 10 highest emitting materials. And so you can see in which assembly of the building they are and what the actual material is and what its contribution is. And again, all of this is aimed at making it easy to go find where are these carbon emission hotspots in this particular design, and go back and see if there's anything you can do to address them. So just a few examples of how the tool gets used. Obviously, you can just sort of compare materials together, within each sheet of the tool. But in this case, I was interested in looking at two different versions of an assembly. So I have a light wood frame wall with mineral wool batt is the insulation, and 100 square meters of that wall has 1,594 kilograms of emissions. And my assembly 2 model, I substituted that mineral wool batt for dense packed cellulose. That material has a very low, it actually has a carbon storing footprint. And so, with that material, the carbon footprint of that assembly has gone down to 152. So, I made a 90% reduction in the emissions of a wall assembly with one material substitution. So that's the kind of thing that you can learn as you sort of look more closely just at assemblies. You can also compare different types of assemblies. So here's a similar snapshot. The first one is a stud frame wall. The second one is an insulated concrete form. So this is using a foam-based insulated concrete form. And assembly 3 is a SIP wall. So with an EPS foam core and an OSB on either side. I've set all of them so that they're all at the same R value, so that the thermal performance is comparable between them. But you can see there's quite a difference in the carbon footprint of these. And the middle one, the ICF, as it's shown there, is several times higher in embodied carbon than the stud wall. And the SIP wall is a little bit more than the stud wall, but not a whole lot. So if you're sort of thinking about what kinds of assemblies you might be wanting to use in a building, you can model them out in this way. And then here's one more snapshot where we're keeping the structure and the insulation, but now we're adding exterior cladding to these assemblies. You can see it's now highlighted in blue. We've gone and picked some cladding from the cladding page of Beam, and this is just to demonstrate that what looked like the best assembly, this wood frame assembly, if I put brick cladding on it and magnesium board on the inside, suddenly its carbon footprint has really shot up. It's over 7,000 kilograms. The SIP panel, because in this case I decided to put bamboo cladding on it and wood as the interior cladding, it's now looks a lot better than the frame wall. So, one of the things that we're hoping people take away from the tool is like, there's not sort of like one magic bullet strategy. There's not one magic bullet material. It really is, you have to look at everything you're putting in the assembly, and there are trade-offs to be had. You can, if you are, say, wanting to work with SIPs, you don't have to abandon them just because they have a slightly higher carbon footprint than other wall structure assemblies. You can address it by changing out the cladding and suddenly making it a better option. So, this is the way that we sort of envision people being able to use the tool to sort of get towards some better results. And then obviously, once you go beyond particular assemblies, the whole building strategy works the same way. So on the left, is a building modeled out in a sort of baseline version, and it has 81,000 kilograms of emissions. And we took the exact same building, same size, same performance, everything about it was the same except the materials. And we brought that down to 20,000 kilograms. So about a 75% reduction there, using the tool to kind of figure out, where are the places where we could be either changing brands of material, changing types of material, or even modifying our sort of assembly approach to get to a much better result. So a few last things before I wrap up this section on the tool. We try to be very clear that Beam is an estimator tool, and not really, it's not trying to give you down to a kilogram degree of accuracy here. One of the things that may make it not 100% accurate is that we're making assumptions on the material takeoffs. So we're using industry standards for framing areas and basically all of the choices that we would need to make to calculate material takeoffs from the dimensions that you input. And so they might not reflect your practices exactly. There's also no factor here for waste. So for those materials where you typically do order 5 or 10% more than the building's going to require, that won't be reflected in the Beam results. And we're also not doing anything in Beam currently to evaluate the quality of the EPD data that we're working from. So sometimes some EPDs are better than others in terms of they've actually used really specific, say, grid carbon factors for where their factory is, and somebody else's EPD might use a general sort of statewide average. So there will be some variation between them, but we're only using third-party verified EPDs, and so we're not sort of making any judgment than another. So I'm going to pause there. I'll stop sharing. That was sort of the intro part to the tool, and happy to pause here and take questions on the tool itself, and then Jacob will take over and sort of put the tool in context and how it might apply to your practice a bit more.
Chris, there's some great questions on the chat that I was trying to keep up with. That I think I got most of them, but if anyone didn't have their question fully answered and then one just came in curious how the biogenic carbon storage is calculated, which is always a juicy topic, so that might be a good one to hit on.
Sure. Okay, I can start there. And do you mind, Jacob? Will you pick the questions out and kind of
sure, I can
throw them at me? Okay, that'd be great. It's hard to read and talk at the same time.
Oh, I know. So, I was trying to block for you there. Totally.
Okay. The biogenic carbon storage, the way we calculate it. So one of the interesting things in the wonderful world of EPDs right now is that by the current ISO standard, a manufacturer can actually address biogenic carbon in one of 3 ways, and they actually all give you very different answers. It's an anomaly, and it's strange, but a manufacturer can either choose to ignore the presence of biogenic carbon. They can assume, it's called the +1 -1 approach, where you say, well, there's a certain amount of biogenic carbon in here, but it's all going to come out in the end, so let's just call it 0. So it's kind of the same as ignoring it. And then you can sort of alternatively show it in the A phase of the life cycle assessment and show the re-emitting of any of that carbon at the end of life phase. So because there are those 3 different approaches, but we want the tool to give everybody the same information, we do our own calculations to provide you with that 3rd option, which is sort of showing the amount of biogenic carbon that is in a particular material. So we're figuring out from the EPD, it'll say, this material has 86% wood fiber in it, say. So then we figure out, okay, so that wood fiber, its carbon content is 45%, dry weight is carbon, and kind of do the math to present, how much carbon dioxide equivalent is actually stored in that carbon, and then use that in Beam. You'll sort of see that we have both emissions and carbon storage shown in columns in Beam, and we also show a net where you sort of like have the emissions and subtract the storage from it. And so if there's more storage than there was emissions, that's where you'll see some of those negative numbers. So we've tried to treat them all equally. The one thing to sort of note is that we do not consider carbon storage in any virgin wood product right now. Most people are surprised because quite often timber products are where you think of carbon storage happening, but we're trying to be as climate science based as possible in the use of the tool and the way we're generating our numbers. And figuring out how many carbon atoms are stored in a piece of wood in a building is pretty easy, but there's a lot of uncertainty as to whether the fact that those carbon atoms are in your building, whether or not that's helped the climate, because timber is really different than most other biogenic carbon materials in that the tree that is storing that carbon is typically cut down before the end of its life, well before the end of its life. So you're actually stopping a future carbon sink in the years you're taking off that tree's life. You're also leaving the root mass of the tree in the ground. So about 20% of the total carbon volume of a tree is left in the ground, and that rots and goes back to the atmosphere. And then of the tree that you've taken, typically less than 50% of that turns into a wood product, and the rest of it is either left to rot on the forest floor as slash, or is sawdust or bark or other things that are typically burned at the mill to heat the kilns to dry the wood. So if you think of it just from a really basic math point of view, if a tree has 10 tons of carbon in it and you put 5 of those tons in your building, but you put 5 tons in the atmosphere in order to put that in your building, you haven't helped the climate. There's no less CO2 in the atmosphere when you started than when you finished. Whereas most of the other materials we're counting are either from the waste stream, where we know that if that material didn't end up in a building, it was going to end up in the atmosphere. So, cellulose insulation is a great example of that. That waste newsprint or cardboard or whatever the raw material is, had been thrown out, was in the recycling stream, was not bought by somebody who was going to turn it back into paper or cardboard. So it was likely to be either incinerated or landfilled and would have become an emission. So putting it in a building kind of counts as storage. Same goes for agricultural residues like straw and hemp, where, unlike a tree, that material grew in one season, but if we left it alone, it's done growing. So, if you leave the tree in place, it keeps storing carbon year after year after year until it dies. If you look at a crop, it grew this year and it wasn't going to grow anymore. And so, stopping that carbon from going back to the atmosphere by having it burned off in the field or rotted off saves that carbon from going to the atmosphere. So that's our sort of process for figuring out what gets attributed with storage and how we do the calculations. And there's a lot of nuance there, and there's a huge amount of work going on right now to figure out how to do that better. Maybe the waste stream fibers and the ag residues, we should calculate them differently. None of that shows up in Beam yet, but as the industry sort of figures those things out better and comes up with more standards, we'll definitely adapt Beam to do that.
That's great, Chris. There's maybe one more question if you're game for
Sure.
one more.
Yeah.
Has a standard practice, a couple of questions about renovation that I took a quick stab at, but this one's a little more explicit, so I'd love to hear your take. Has a standard practice been established for how to do carbon accounting with renovations? For example, if you're renovating 20% of the floor area of a home, how, if at all, do you account for the parts of the house you're not touching? Would the MCI include just renovated areas or the whole house?
So the way that is typically being done is you're accounting for any of the new materials that are going into that renovation in the exact same way. And so people are using beam for renovations. You know, you probably aren't putting in new footings, so you kind of skip that part of beam. But if you're, you know, adding insulation, adding new windows or changing out windows, you know, so you would be accounting for that, and you can use beam to do that. And then the other piece that you typically account for is the waste emissions that might happen from materials you removed from the building. And that's something that you can't do in beam, but that if you have the sort of the EPD for the product, it will sort of tell you what its end of life emissions are expected to be, and you could add it up that way. And then you basically, there's a zero on the books for everything that you leave in place. So, you know, if all I'm doing is changing out windows, you know, I'm really just looking at the carbon footprint of the new windows. And because there's hardly any emissions from windows at the end of their life, because the glass doesn't rot or, you know, decompose in a way that that creates emissions, you know, that's almost the whole story. If I'm getting into taking some of the flooring out and some of the cladding off, and, you know, some insulation out and new insulation in, it gets more nuanced. But you would be able to use beam to account for any of the new materials that you're adding to the building, and you'd have to figure out the waste stream stuff separately from beam.
And the good folks at Arcantol just point out there's a brand new tool that just got released specific for renovations called the Care Tool.
Care Tool. Yeah.
That already link is in the chat, so go there, but not yet.
Okay, so should
right.
should I hand it over to you? And you'll,
sure. Yeah, I'll take us to the end here. All right, so I'm going to dive into, let's see, can you all see the screen correctly? All right, I'm getting a nod. I'm going to be looking off to the side here where I can actually see what I'm talking about. So I'm going to be talking about how to make this actionable. Chris gave a great lead into sort of what compelled us to want to look at this issue in the first place. We're sort of taking for granted that we all have a shared sense of the urgency and importance of dealing with the climate impact of our built infrastructure. That's in like base assumption of the folks in this room that this is actually really important and worth paying attention to. And so what we found is that since we've released the tool, and as so I should probably introduce myself since we didn't do that at the beginning. I'm Jacob Deverett-Hewson. I am one of the co-owners and the Director of Building Science and Sustainability for New Frameworks. We are a design build firm here in Vermont. Our build practice is mostly on the residential scale and light commercial, and our consulting and design work scales up to mid-size projects as well, focusing very closely on all the content we're talking about right now: climate justice response for the built environment. So what I've found within our company, and then with the consulting work that I've been doing for a number of other engineering and architectural and construction firms, trying to help them figure out how to do this work, is it's one thing to have the data, it's one thing to have the tool, but we're not all super well trained to like conduct good analysis and figure out how to like ask good questions and get good answers efficiently. And that's a really big deal for kind of a couple of reasons. One, we have very, very little time to make a whole lot of change. There is a really high level of urgency around us changing our practices, tilting the trajectory of our industry's impact, and sort of shifting the paradigm for construction to be able to meet the climate requirements of the IPCC. So figuring out how to make this actionable quickly is really important. Also, you all are all architects, and you know how difficult it is to add anything else into your purview. You're already thinking about 15 to 20 different things that all need to be factored into every decision you're making, and you have a very limited amount of fee with which to do it. So figuring out how to very efficiently and effectively hone in on which questions to ask when in the process is really critical. So I've been working for a while to try to help climb that learning curve. And so the second part of the presentation will be sort of trying to address that workflow and optimizing our practice. So before we actually start counting carbon, that's, you know, I'd say maybe third order thing to do is actually adding up all the carbon. There's a bunch of things that check out first. For those of you that are not already in the practice of looking at your carbon impact, figuring out what barriers or opportunities are available for taking action. Barriers are often fee, time, bandwidth, knowledge. Opportunities are usually around, we have a client that really cares, or we have, you know, a goal that we're trying to hit, or a certification that we need to match. or some other opportunity to build in a little extra fee or devote a little more attention to figuring out how to build something new into the practice. So identifying those from the get-go can help avoid frustration and find the right match of how much work and with which project is appropriate. I'm a huge fan of goal setting. We're going to talk about that, but identifying what your goals are and what you're trying to actually get out of your accounting is really critical to make sure you're not over or under functioning in the amount of work you're doing to come up with answers. And so associated with that, well, what are the questions that we have to answer to hit our goals? Again, we'll kind of map out some examples there, make it a little more tangible. Where you are in the process makes a big deal. If you're thinking about this in ideation, you have a lot of opportunity. If you don't really start thinking about this until construction documentation, you have a much narrower realm of change that you can make by that point in the process. And so what questions you ask and how you use the tool will vary depending where you are in that process. And there's a bunch of different tools that you can use. We're looking at Beam, but there's many others. I'm going to show a quick case study at the end here that looks at Beam used in concert with another life cycle analysis tool, which is different and is built from a different data set, but is looking at some similar things. And then who needs to consume this? I mean, really, none of this is useful if it's not going to compel action. And good data has never convinced anyone of anything by itself. It's just valuable to help tell a compelling story and to help enact change and take action. So how this data gets consumed is also part of the process here. So I'm going to give some examples of this and then spin you through a case study, take some questions, and then release you to your day. So many folks in the design process have what's called owner's project requirements. I know it's a relatively standard, particularly in larger phase projects. We started using this even in our residential projects because it's really, really helpful and useful place to just formally capture all the owner's intentions and goals and desires. It also gives a really good structure within which you can help start having a dialogue and conversation and establish formal goals around reducing climate impact. And so it becomes accountable. Everyone's accountable. The owner's accountable to the things they're establishing as their goals. And then as the architect, if you've got a band of consultants you need to kind of bring along with you and ensure that the structural engineer isn't going to fight you to the death about just throwing more steel at the situation. If there is an owner's requirement that is documented that the basis for design has to respond to, that holds a lot more weight than as an architect just saying, I care about the atmosphere. And the structural engineer is like, meh, show me why I should care too. So there is some process here that you can, especially if you already have some established process around documenting your goal sets and having dialogue with the owners and getting the owners' weight behind some of this. That can be really useful in coordinating a team response. Because as you saw with Chris going through the tool, every single material in the entire building can have a response. So it's really a multidisciplinary exercise in how to reduce carbon across the entire building and not just within a single division. And then, of course, the basis of design gives you a very formal opportunity to respond to some of those directives. So just a couple of examples of goals. I find this to be useful just to get a sense of what's good or not good. I see a lot of like, we're going to reduce climate impact and energy use and materials. And that's great because it's specific and kind of relevant to the cause, but there's no way to measure that. It's not quantifiable. Like reducing impact could be, that's a pretty slippery fish there. And so it's a pretty easy goal you could drive a truck through the accountability of a goal like that. And so something with a little more teeth tends to make for a stronger goal. There's a lot of programs and standards that reference a reduction against the baseline. And we'll talk a little bit about kind of how to orient around that. But if you see a baseline reduction goal, an example would be reducing your EUI, which is your energy usage intensity, 30% below baseline, reduce the concrete global warming potential by 20% below baseline. That's great because now you can measure something, you can quantify it and defend it and hit a target. Defining baseline can be its whole own process. And even that can be kind of game that process. That can be slippery too. It could just be more work if you need to define a baseline. The reporting and research that Chris mentioned that Voice for Climate Action has done goes a hugely long way for getting some benchmark data established for residential construction. So that is, I would point there for the residential space is a good place to start for defining a baseline. Also, EUI is not the same thing as climate impact. Energy is not carbon. It's related to, there are carbon emissions associated with energy, but it's not the same thing. So if you're talking about energy, set an energy goal. If you're talking about carbon emissions, you need to set a carbon emission goal. And you may need both. Both may be relevant. And then, of course, concrete is a great place to look because we use a ton of it and it releases emissions. But if you're doing a lighter frame construction or there's not that much concrete to begin with, that may not be the biggest problem to solve. So overly defining what you're trying to hone in on can be really good or really bad. And that's the sort of thing that just comes with experience and starting to understand the numbers more and getting a better sense of where do we need to hone in before having to do the rigor of going through a whole project. Really strong goal would be a max EUI of 25 kilowatt hours per square foot with no combustion, 100% renewable offset, and a max cap of embodied carbon. And that's great because everything's defined, it's performance-based, you can get there in a number of different ways. It's not overly prescriptive, it's specific, it's relevant, it's measurable, it's all the things you want to see. Is it attainable? Can you actually hit that goal? Is that a reasonable goal for you to try to attain? Again, that's the sort of thing that comes with experience and doing more of this analysis to get a sense of smell. Those of us that have been in the high performance or the energy efficiency space for a while have a sense of what EUI 25 is. That may be familiar because we've been doing this for a generation. Embodied carbon numbers, less so. And again, I'll point back to the Builders for Climate Action research. Chris was identifying, in the mid 100s is sort of like a median average we're seeing for a whole bunch of those residencies. So in this case, 500, that might actually be very easily attainable if that's a similar building type of building too. And then certification can be a goal as well. If you're going to be in the ILFI zero carbon certification, there's your goal. The biggest thing to understand there is it doesn't take any responsibility off of you as the architect of identifying is that a good goal and what's required there. I like to think of certifications as basically a proxy for your project goals. You're outsourcing your goals to an organization that may be better positioned to evaluate what good goal setting is. So we do that with LEED, we do that with any certification. We're like, well, we're going to say what they said is good, and that's going to be what we said is good for this project. And it's our responsibility to make sure that that certification is actually appropriate and relevant to the project. Just because it says net zero carbon doesn't necessarily mean it's a good standard or that it's the right standard for your next job. All right, let's look at like a couple of different ways of thinking about modeling. Like this versus that would be maybe the most like obvious one or the easiest one of entry, especially if you're not like it's overwhelming or too much to commit to like looking at an entire building. You're just trying to get some initial looking at some like just different combinations of material options. So in this case, we're looking at two different ways. One would be the one I was just mentioning around like an easy material entering point would be wood fiber board or mineral board. We've been using mineral board a lot. We're interested in using wood fiber board. What's the, what a difference be there? And as Chris mentioned in that sort of layout of the tool, it makes it super easy, just literally at a glance, just looking within any of those project tabs, what the emissions differences are. So that'd be like a direct comparison between two emissions. I really love using Beam early on in schematic design because I have an opportunity then to look in this example, looking at different massing schemes. Again, for those of you that have an energy modeling background, there may be it's a very sort of similar analogy where you may do a basic box model for energy modeling early on to get a sense of what's the impact of adding 7 additional corners to this building. You can get the same information. If you have that information early in SD, you can make those decisions and changes inexpensively and cheaply. If you don't figure this out until design development, it may be a little bit too late. Another similar version is how much better or worse is this than whatever my baseline is. So again, that baseline could be industry average. It could be the last thing I did. It could be what the CM is proposing, whatever you want to assume is a baseline. But that would be I'm set a standard, and now I'm looking at am I better or worse. And again, these are all sort of comparative analysis. You're probably ruling out a bunch of variables. You're limiting your focus, and you're comparing directly between 2 different scenarios. That's different than like another amazing power that I think Beam has, which is to do what we call absolute or like a full quantified analysis. And that's how much does this emit? You're not comparing it to anything. You're just looking for a total. What is my total impact here? That begs a lot more sort of work on your shoulders as an analyst. And you need to decide what's going to be included, what's not going to be included, how big of a that's so some of these like first yellow categories are what are we including or not including, and Chris mentioned what is or is not included within the Beam tool. So you may be limited by what you can actually count based on what the tool has to offer. That middle would be, sort of the boundaries, like what are we fully including within or not within the analysis. And again, different tools will have different levels of support around that. This one's looking just at materials. So if you need to look at end of life, you would need to look elsewhere. And then the quality of the data on the right there, that's one thing that I think Beam shines at, in that it's using actual real product data. So you can get quite specific in terms of the on a product by product basis of what, and in the case of concrete, you may even be able to get a custom developed EPD for your specific concrete mix and use that level of data accuracy. So those are all questions that will govern more of that type of analysis. Does it meet program requirements? Well, that's pretty straightforward. You look at what the requirements of the program are and make sure your tool is complies and Beam works as a verification tool for many programs, and that would be a different set of analysis. Do I meet the program requirements? And that's usually going to be again like a material carbon intensity value that you have to meet, for example. Who's the audience? So lots of different tools have lots of different sort of densities and types and formats of information. I won't linger too long there, and I apologize for the slightly grainy clip that I pulled from Beam. It did not expand very well, but it just gives them, some of this is visual, some of this is tabular. And depending on who you're talking to, if you're talking to your engineering cohorts, more tabular information is probably going to be really useful and valuable. If you're talking with your clients, a spreadsheet may not compel them, but looking at really big and really small bars will communicate that information really quickly and easily. So just consider that as you're going through the analysis, who's ultimately going to consume this and how do I use that information well. All right, in the interest of time, I'm just going to kind of keep moving along here so we have some time for questions at the end. I'm going to just walk through a relatively recent project. It's under construction right now. The modeling is all done. As a case study, just to show how I've been working with the tool and just putting some of what I was just describing into action here. So this was for a roughly 20,000 square foot institutional building for an East Coast private university. The sort of brick building on the right corner here. Can you all see my arrow? Okay, great. So that brick building was existing. It's getting totally rehabbed and renovated. So the renovation questions that we were answering, that was our process for that building. And then these sort of like two other buildings, this sort of cube building and then this long bar building, all glommed together to make one fully integrated structure. And so this is classrooms and auditorium and offices, that type of space. So in pre-schematics, when we were still in ideation before we fully launched, we started early talking about this. Is actually selection criteria on behalf of the college was to meet their climate action plan, which included having this is the first building built under their new climate action plan. And so they really wanted to make sure that it was going to be built with climate impact metrics in mind and evaluating part of the design process. So we set out with an early goal, 500 kilograms of CO2e, and honestly, we didn't really have a really great sense. This was a couple of years ago that we set that goal now at this point. And it was still early on enough. We didn't have a lot of great benchmarking data, and we sort of lifted that metric from another certificate, from the ILFI certification, and said, all right, well, we don't really know, but we'll start with that because that's a data point we can reference. We identified the zero carbon certification as a certification maybe of value for the project, and so sort of bring that into consideration. The design team is going to use Tally, which is a life cycle analysis tool that, among other things, also looks at global warming potential. But it was clear in our workflow that we're going to have that tool sort of fully up and ready in time, and that Beam was actually going to be really useful for looking at product level data. And so we decided we're going to kind of work with both tools to answer different questions, some of the different questions that I was posing at the beginning here. And had some sense of what the construction workflow was going to look like. There was going to be a CM, so we'd be able to bring their knowledge into the design process. There was going to be a submittal process that we could evaluate the materials and make sure that we're meeting our emission benchmarks for each of these materials. So we sort of knew all of that in terms of how we're going to be able to track carbon all the way through to the product level. And then we already knew walking into it what our assembly approach was going to be. And so we sort of had all those things named and identified kind of heading into the process. In schematic design, what we did by the end of SD was we sort of validated our pre-schematic targets. Like, yep, this still seems appropriate. Actually, we were blowing past them, and so recognizing we may need to amend those. At the end of SD, the client identified, yeah, we should keep that certification as a basis, but they decided they weren't committed to following all the way through with it. So we were still referencing the certification, but it wasn't a formal requirement. And that was really important for us to name coming out of SD as to whether or not we're going to have to hold that accountability or not. And we named a bunch of our strategies. And when I say named, I developed a report that had all of these pieces identified and circulated within the entire project team and presented to the owner. Again, that transparency and accountability around our process. So we talked about what the modeling approach is going to be, making sure that all the different consultants were aligned around that, naming what our data sources were going to be, looked within structure and enclosure and interiors, what are the areas that we're going to focus in on as we're kind of leaving SD had enough of a sense like, cool, this is going to be what we focus on and this is how we're going to get there. And this was established sort of collaboratively within the design team to make sure that, yep, we can all get behind these approaches and they work with each other. So a lot of coordination and sort of a collaborative approach for that multidisciplinary kind of package of solutions. We also looked at the end of schematic design, looking at the CO2e intensity both with and without storage. And I did a little bit of post-processing to look at, okay, if we were to give some storage credit to FSC certified wood, because that certification program allows for that, what might that look like? And so I do, in a lot of my reporting, I'll look at both with and without that storage, which both gives some bracketing of how much we're dependent upon good, quote unquote, good wood to offset, and also the unlikelihood of getting really good verification in the supply chain. And so really being able to look at these buildings as, you know, not pretending that they're steel, but not necessarily giving that storage credit for all the same reasons that Chris mentioned so well before. So what you're seeing here, I broke this into 3 different little buildings so we could kind of get a sense of each, because they're different construction types and different sort of material components. So you can kind of get a sense of what they're looking like individually and then together. And what we found, even without giving any storage credit for the wood, we were well below our target. Okay, phew, good, we can proceed. There's not a crisis yet, or we don't need to be, you know, super guarded about whether or not we're going to meet our standard. If anything, we need to set a lower standard. And so we spent a fair amount of time looking at what a lower standard, a lower goal might be. Here's an example, just another example of the output coming from Beam. You can see a lot of rounded numbers. Again, this is SD. We didn't have a ton of information at that point. It's not like we had all of the layers assigned. But we did have a pretty good working understanding what the assemblies are going to look like and could kind of zero in really quickly. Yep, footings and slabs, ceilings, and what was sort of packaged into that ended up, roofs, what was packaged into that ended up, yeah, there's a fair amount of emission material in there for a few different reasons. So that just gave us a pretty good visual and quick cue as to where to focus on, and seeing how some of the negative emissions from our recycled insulation materials and so on and so forth are really working in our advantage. At the end of DD, I'm just going to kind of march right along. By the end of DD, we had a full BIM model built out in Revit, and we were able to create a tally report. And again, tally is a plugin that goes with Revit that is a life cycle assessment tool. So it's using industry average data from a life cycle inventory database, not product specific data and EPD data like that Beam uses. And it's also looking at a series of different environmental impact categories, which we were basically ignoring for our analysis, and has a way more granular accounting, because it's looking at every single material that you're defining in your Revit model. So there was just a different density of information. I kind of compared between SD and DD to get a sense of how we were tracking and how things were changing. Always a good exercise, even if we were staying within Beam, that would have been a really important exercise to see, okay, how are we doing? Do we make changes? And it's not unlike cost estimating. You cost estimate at the end of SD, you do one at DD, like, oh, it went up 20%, shocker. And, you know, so planning for some of that and understanding what increased and then trying to figure out why it increased. There's both a quality control value. I've caught numerous errors in multiple different tally analysis by comparing it to a Beam output and be like, these are really different. Like, oh, we counted that stairwell 4 times or what have you, or we missed an entire like wall in our Revit modeling. That's actually surprisingly easy to do and trying to get a good BIM output. And so there's some good QC that comes as well from using a really quick, fast tool like Beam, even if you are also going to use a BIM integrated LCA tool. So anyways, just give some more information, making sure we're on track. Another thing is look at the percentage of that change in there, which is another good way to really hone in and be like, oh, floors like dramatically increased. Does that make sense? Was there an error there? Did we make a design change? And can we still hold for that design change and still hit our climate, our material emission goals? Moving along to construction documentation. Again, kind of looking at, and we have these sort of categories. are slightly different than the categories from Beam, but they did a fair, again, a little bit of correlating. They're not super far off. And again, we're just looking at by the very end of CDs. Again, we're not making any real major substantial changes at that point. It's really more of a reporting effort, but also again, it shows us, did we meet our goals? Are we on target? How much what does that look like with or without the bio-based storage for wood? Again, that's not information you're necessarily going to get out of Beam, but in the case of this certification where they were allowing us storage credit for FSC certified wood, it became relevant to kind of weave that into the analysis. And it just gives us a sense of, yeah, wow, there's clearly a whole lot of wood in our floors, and this had some CLT, some mass timber elements in there that were accounting for that. So just giving us a sense of how are we doing, how did it turn out by the end of CD before we head into the final process in CA and accepting submittals and getting down to the product by product basis. And we could tracking what our target was and how the project moved across those different phases is also really useful information for predicting your next project. Like, ooh, we should really put like an extra like 20% slop on SD, because the more detail you get, the more information you get, the more emissions you're gonna continue to account for. So yeah, just different ways of being able to look across the phases to see the trajectory of your goal setting. Just to get more tangible in the final minutes here of what some of those strategies were and kind of how this is now switching. What I was just showing you was reporting that I had mostly for our internal team. What I'm showing you now, give credit to Brunner Kott, who is the architect on this project, and Christopher Nielsen, who is the lead, prepared this really great sustainability report for the client. So that's what I'm showing you now. This is the communication now back to the clients to let them know what our solutions were and help them tell a good story to their stakeholders. As a university, it was really important that they could tell the story of this building and validate why it was in alignment with their climate action plan. So we help them with this much prettier version than the slides, the graphs that I put together for our internal team. So just looking just a few excerpts from that. These were the various material solutions that we used. We really worked to keep the old masonry building intact. And again, we have all of the structure, all those emissions were already released a very long time ago. So we're trying to extend the life of the materials that were already existent and for whose emissions were already released, as well as being really, speccing very specific types of materials and types of structures to, and installations to get to the end zone on our accounting. This is the industry average sort of cap for the benchmarking that the Carbon Leadership Forum had done for this type of building. 500 is the standard we were shooting for. 400 was sort of the like good building median, again, using Carbon Leadership Forum's prior. They just released some new benchmarking, which is super helpful. Again, this is if you're trying to compare to a benchmark, where do those numbers come from? CLF has done a great job of helping support that. And our model with and without the biogenic carbon, showing what's here in purple and then that dashed line. So that was really helpful to see how good of a job we've done. On the left here, I won't take the time to read through all of it, but we talked about the specs, the elements that made it formally into our specifications that helped us achieve those low outcomes. And zeroing in here on finishes, it was really cool to see. There was just like being a little bit dramatic, but there were like square miles of gypsum and carpeting in this building, just like a huge volume of materials. And so normally we think of insulation and structure, especially structure in larger buildings, as being like the big problem to solve. In this case, it was double stud light wood frame construction. We did a really good job with some CLT elements and mass timber elements. We did a great job of really keeping the structural loads down. There were some really big emissions in sort of conventional finishes. So when we were using the LCA data, which is just industry average, it doesn't get any specific products, we're seeing like a pretty big plume of emissions for gypsum and carpeting. Carpeting partially because it's a high emission material, but also just because we use so much of those materials in this project. And then when we used Beam and an EPD basis to dial into the details on, well, we're going to choose a super low emission carpet, and we're going to use sort of the best in class gypsum wallboard. And build those into the specifications. And this is where we identified, hey, we have a CM that's on board, and we can validate that we can get those materials, and we can ensure that we'll get a submittal and can improve those particular materials and really validate that all the way down to the product level during procurement. I mean, that knocked 53% of the emissions out of our finishes division, which was 17% of the total emissions of the building for carpeting and drywall. And those are the types of successes that I get like thrilled about, because cool, if we can dial in a carpeting and drywall spec and knock 17% of the emissions off the building, like that's some really low hanging fruit. We're like literally kicking apples around on the ground if we're just changing a drywall spec to get that type of reduction. So that's just an example again of where we wouldn't have been able to get that information out of an LCA tool, getting to product level data and being able to defend a specification was a key component of getting those low numbers, and quite simple to do with the right data set. Chris, feel free to jump back in on this one, but really just trying to show that there's like a real like sort of host and diversity of different ways of achieving really ultra low, near and below net zero carbon buildings. A mix of different buildings that are really at that like ultra low, hyper mile, low carbon enclosure, finish and structure deliveries. And some of these are residential, and some of these are commercial, and a variety of different architectural styles. And there really is just a wealth of opportunities of how we can achieve these goals that don't need to be restrained by like a certain cottage aesthetic, or only relegated to small residential construction to be able to get there. It's the only other vignette that I'll share briefly, since I have just an extra minute here, that I didn't actually doesn't show up here, but we found that in interior acoustic insulation, by changing the spec from fiberglass to a cellulose bat product, we went from emitting like 2.5 tons of carbon to storing 4 tons of carbon in the interior walls of the building. And the owner was so thrilled with that. The concept that we were just banking and storing carbon throughout all the interior partition walls, and something as banal as acoustic insulation became this like major amplifier of active carbon storage in the building for something that's like not very expensive. Like acoustic insulation is not very expensive. That was just another great win. All right, we'll wrap up there and take some additional questions. Really want to encourage you to go ahead and download Beam, take it for a spin, work with the tool, and if you're finding it useful, please contribute and donate to the cause so that we can continue to improve and build out the tool. We're very excited about this tool's future. Builders for Climate Action is giving a series of different trainings. These are really well-developed and high quality trainings, both on the tool itself, and again, how to think your way through analysis and how to do good high quality analysis with this tool. And it's a really helpful way of climbing up the learning curve sort of quickly and efficiently. You can see those at the bottom there, coming up at the end of this month. Chris, jump in if I missed anything critical there. And otherwise, happy to take some questions.
No, that was great.
I'm also horrible at looking at the chat. I have not looked at the chat since I started talking. So if there's anything you want to shout out there, or people want to.
It's been dead quiet since you started talking. So
all right.
You answered all the questions.
Yeah, like, is that a good thing? Is that not a good thing?
Can I
well, feel free, unmute, please. Here, I'll stop sharing. I'll leave this on, but yeah.
Can I ask a maybe not that smart a question, but I remember from the beginning of the tool, you were showing that pretty much everything exterior can be included in using the tool. That's what I understood.
Oh, not within the building itself.
Yeah. So, but I was thinking a driveway, wouldn't that be a simple, like there's a lot of concrete going in there. Couldn't that be part of, can you use that in the Beam tool? Or you can just model your driveway anyways. Or,
Yeah, Chris, how would I
I think
that?
Well, you're right. I mean, the driveway could be modeled, although there currently are no EPDs for asphalt. So unless you're doing a concrete driveway, it's actually hard to model. I think, to some degree, we just kept it like to the building itself for simplicity's sake, because as soon as we get out into the landscape, there's materials and products for sure, but then there's also bigger questions. How much soil did you move and disturb, and where did it go? What have you replanted, and what impact is that going to have? And I think all of that is super important. And it was just kind of like, more than we could tackle with the tool at the time. There
Yeah,
is
okay.
there is a really great landscape tool. The name is probably going to come to me as soon as we get off the line, but
Sasaki put it out there. I can't remember the name of the tool. I can't remember the name of the tool, but Sasaki is the company that released it. So if
Okay.
you did like a Sasaki carbon tool, you'll find it.
Yeah.
Yeah, I was thinking a concrete driveway, and I guess I just want to mention something I learned at the conference that I went to was that Central Concrete Supply Company, which is local here to the Bay Area, they have rated concrete mixes that have their concrete the carbon footprint. So you can pick, you can work with your structural engineer and pick a concrete that has a lower emissions.
Yeah, that's great. That's starting to happen more and more. In Beam, what you'll find is we use the national averages for different mixes. So the National Ready Mix Concrete Association sort of has some benchmarks for, you know, different amounts of SCM content, and so that's what's there in Beam. But yeah, more and more, and especially in California, you have, you know, supplier by supplier, those EPDs exist. And it's always, you know, it's one of the, again, one of the sort of like really easy wins to look at that mix and see if you can find a substitute that'll do the same job with a lot lower carbon footprint.
Yeah, we found that our structural engineers are like the superheroes behind a lot of our projects. And a structural engineer that really understands, you know, low impact and low carbon approaches just in general. I mean, the mixed chemistry is just one of a series of different strategies in structure, from reducing strength requirements, reducing massing requirements, and like sort of alternate approaches in the sort of like grid approach for developing the structure. There's a number of different ways to get in there, but yeah, oh my gosh, we've worked with some really fabulous structural engineers that can really dial in the right amount of SCM. And when I say SCM, supplementary cementitious material like fly ash or slag are probably the two most common. And we'll even tune in, like trying to max out the amount you would get out of your footings versus your walls versus your slabs, and can really stretch for that, and can communicate really effectively directly with the ready mix plant. We're finding contractors are like a step or two behind having that internalized, but the ready mix plants have seen a lot more of it. And they're generally like very familiar, and some of them will have, like you're just mentioning, like off the shelf mixes that they've already done that they have in their database. Some will just, you know, they'll formulate for whatever's required, and a lot of these materials are actually not uncommon. They just haven't been looked at particularly from a Portland reduction like view, and so that's where a good engineer can partner the ready mix plant and get some really amazing results without adding cost. I mean, that's the thing that's so exciting about this, is like I've yet to see a mix where really maximizing fly ash or slag has like significantly changed the delivered cost per yard of the material. It's the biggest thing has been trying to get our hands on it. There have been some supply chain issues over the last year or so. That's been the greater liability, but it's just such a yeah, big shout out to the engineers.
Yeah, and when the mixes are already pre-mixed, then you know the carbon footprint of it and you know the strength of it. So it's like a pick and choose kind of a thing.
Exactly.
You can bring it to your structural engineer and say, you know, here's
does this work? Yeah, can we use this one? Exactly. And in Beam, there are mechanisms at the bottom of the pages where you can put in some, oh wait, no, we don't, never mind, take that back. The custom inputs are not in place, are they, Chris?
No.
Yeah, never mind. I was referring to an earlier version that I used myself in the past. Never mind, I rescind that comment.
Well, guys, that was fabulous. I thank you so much, Jacob and Chris and Kirsten. I think we're out of time, but that was really great. My head's spinning, but in a good way.
We had a huge turnout.
We did, which is
like
fabulous.
50 people. It was awesome.
Yeah, excellent. And everyone,
worth your while coming.
Exactly. And as a reminder to all, put your information in the chat if you want credit, so Sydney can take care of that for you.
You can also email me. I'll put my email in the chat in case you, for whatever reason, don't have it handy.
Yeah, thank you so much. That was great.
Okay, yeah, thanks everybody. Thanks for the invitation. Really appreciate the chance to be able to talk to everybody.
Real pleasure. Thank you all so much. Be in touch with further questions.